Now that you've had a chance to look at some basic graphing strategies, we are going to get a little more detailed with how we find end behavior. So yesterday we discussed what end behavior looked like in the general sense. But now we need to get a little bit more detailed in our descriptions. So with our end behavior, let's look at just a generic XY axis. When we are discussing end behavior, now we need to be able to describe to other mathematicians what the end behavior is doing. And just having arrows is not going to be sufficient enough. So the way that we describe end behavior is if we were to pick values along the x-axis, moving in a positive direction, we want to know, does the graph or the end move up in this general direction, or does the graph move down in that direction? And so what we say is, as x approaches infinity, meaning as x is getting larger and larger, or moving along the right-hand side of the graph, are we plotting points that are y values moving up, or are the y values moving down? And to answer that question, we say as x is getting bigger or approaching infinity, either the function is moving also towards infinity, or the y values are also getting larger, or the function is moving towards what we call negative infinity, meaning that the y values are going to be moving down in a negative direction. The other description is what's happening on the left side of the graph. So again, as we would pick values for x moving in that direction, we're picking negative values that are continuing to get bigger and bigger in a negative fashion. So we say as x is approaching negative infinity, meaning that it's large negative numbers along the x-axis, we are either going to be having an end that moves up in a positive direction. Again, the y values are moving towards infinity. Or we have a graph that moves down in a negative direction, where the y values are approaching negative infinity. And so that's going to be what we're going to do when you're asked to describe the end behavior. So not just what is the end behavior, but we want to be able to do a description of it. And this is our description. So we're going to modify our chart a little bit, not too much. Still talking about the degree and the leading coefficient. But now we are going to use this description when we're talking about end behavior. Just give ourselves a little chart. And so this is a little diagram where we can look at the degree. So if the degree is odd and the leading coefficient is positive, then our description for the end behavior is as x is approaching infinity, what is happening? So as x is approaching infinity for an odd, our graph goes up towards positive infinity. We can say y, or f of x, also moves towards infinity. Oops, can't see that. So with an odd degree, because our positive leading coefficients mean arrows go in opposite directions, as we're moving down the right-hand side, the y value is moving up. And as x is moving on the left side, your y values are going towards negative infinity. And so this is one of our descriptions, is what happens when our degree is odd and our leading coefficient is positive. And what this is how we're going to describe that the arrows are moving in these directions. So if you look at the graph on the left, an odd degree goes in opposite directions. And so we're kind of using this little chart to kind of help us out. All right, so if we're over here in this quadrant, as x is approaching negative infinity, y is approaching negative infinity. As x is approaching positive infinity, y is approaching positive infinity. So it's almost like looking at are we moving left or right first, and then are we moving up or down? The other description would be, well, what happens if we're odd and negative? Well, think about an odd and a polynomial with a negative leading coefficient. That meant that we were still going in opposite directions, but we were going in this direction. So if I look at this little chart, as x is approaching negative infinity, when I have this negative behavior, it starts here and goes down low. So as x approaches negative infinity, the y values are approaching positive infinity. And we're using a little arrow to talk about approach. Also, on the other side, as x is approaching positive infinity, with a negative coefficient, I'm moving down. And so this is a description of what happens when we have arrows that go like this. So we can create this little chart right here about describing the end behavior, or we could also just kind of think about this smaller chart. If you can remember what happens with the ends, you can move along the x-axis and then jump up to the y end behavior, or when you're moving down, you can jump to the y end behavior. Again, well, what happens then if I'm talking about my degree being even? So let's make another small little chart. And say, well, my degree is even. And it's going to be even on both. And what happens when the degree is even and the leading coefficient is positive? Well, that means that both of the arrows are trending upward. So that's like the upper half of this graph where both arrows have to move up. So again, if I say what happens on the left side, that's going to be as x approaches negative infinity. So as I'm moving down this direction, the y values are moving up, and so the y values are tending towards positive infinity. Same thing over here. As x is moving in a positive direction, because the arrow has to trend up, the y value is also moving in a positive direction. So we say positive infinity. And that's because of your arrows that yesterday we were making go up on both sides. And the other type, the last type, was when we were talking about a negative leading coefficient. And yesterday we said, well, that's what happens when both the arrows are pointing down. So again, look at this little chart. As x is approaching negative infinity, y values are approaching negative infinity as well. And as x is approaching positive infinity, moving this way, for my arrow to trend down, the y value has to also be going towards negative infinity. So these are now our descriptions. If we are asked to describe end behavior, the description is going to be what is happening as x is moving to the left and what is happening as x is moving to the right. So this is our description. But again, you don't necessarily have to think about these charts if you can remember this picture, because this picture actually tells you everything you need to know. So let's look at just describing some end behavior. So for example, I want to describe the end behavior. So let's look at y equals 4x times x minus 2 times 3x minus 4. Now all of these are single factors, and when they're all single factors, all I need is the very first piece of each one of the factors. And so my actual, what we call the leading term, is what happens when I multiply 4x times 3x together. And so right now my leading term is going to be 12x cubed, which means that my degree is 3 and my leading coefficient is 12. So I have an odd polynomial with a positive leading coefficient. And so I need to be able to describe what is happening as x is moving along the left side of the graph and what is happening as x moves along the right side of the graph. Now, again, I can come up here to this chart because this is my odd chart. And my leading coefficient is positive, which puts me up here. And so as x is approaching positive infinity, my graph is going towards positive infinity on the right. And as x is approaching negative infinity, it's moving towards the downward or negative section as I move towards the left. But again, if I can remember that arrows are moving in opposite directions, I can use my little graph instead. So either one. As x is moving towards positive infinity, if the arrow is supposed to be trending up, that kind of tells me exactly what to write. If x is moving towards negative infinity, it tells me what to write. So we're going to do just one more. And this has to do with multiplicities. So negative 2x squared times x plus 1 times x minus 2 quantity squared. And this one's a little tricky. The reason it's tricky is because of this square multiplicity on the right. What this really means is that I not only have my negative 2x squared and a factor of x plus 1, but it really means I have two factors of x minus 2. And so what happens is I can't just highlight the first piece of each one right here, because what I will be missing is I'll be missing this extra factor. So either we need to expand this out so that way I can see how many I really have, or I need to try to think about a little bit of a shortcut. So in reality, if I look at how many factors I have two factors here, I have one factor, but then because I have two factors, the number of x's I have is actually more. So I have my leading term. So let's look at the leading term. So the leading term is a negative 2x squared times an x, but then I have two more x's. So what we can think about is anytime you have a factor that is a multiple, I have to remember that that tells me how many of those x's I have. That's how I got these two right here. And if I don't attach the square to the first term, then I'll be missing part of my leading term, which means my end behavior is going to be off. So right now, my leading term is a negative 2. I have 2, 3, 4, 5. I've got 5 x's, which means that now my degree is 5, but my leading coefficient is negative 2. And so if I want to be able to describe my end behavior, I'm actually going to move this over and I'm going to use my little graph instead. Okay. with a fifth degree and a coefficient that's -2, I'm going to be moving in opposite directions. And I'm going to put my end behavior over here. So as x is approaching -infinity, what happens to y? And as x approaches positive infinity, what happens to y? So from yesterday, our arrows had to go in this direction when my degree was odd and positive, but they went in this direction when they were odd and negative. So as x is approaching -infinity, my y value is positive infinity. And as x approaches positive infinity, my y value is -infinity. And again, this is how we're going to work on describing end behavior today.